Here is the gender variable. Just double click on the gender variable. That is one way, or you can drag and drop gender also. There are null values, female and male. Double click on customer ID or drag and drop the customer ID. That is also fine. But you have to convert this customer ID into count or count distinct. Let us take count distinct. After that, you have to go here, select pie chart. Is the pie chart highlighted? It's not highlighted. Let us see how do we achieve it. Okay. Right now, when I'm clicking on gender, when I'm clicking on customer ID, both of them, the actual pie chart is not getting selected. This is one of the biggest issue with Tableau, that the chart that you want to select may not always suggest you, because here, if you see here, when you are hovering your mouse on the pie chart down below, for pie charts you have to try one more dimension. I'm going to tell you what is a dimension. In general, a dimension is a non-numeric categorical variable, something like gender, which takes male, female, something like education level. They are known as dimensions, and you require one or two more measures. What do you mean by measure? A measure is a value that is numeric, count, sum, average, age. You can find the average age. Depth ratio, you can find average depth ratio. Income, you can find average income. They are known as measures. What are dimensions? Education level, gender, marital status. These are the dimensions. So it is asking us, you have to get some other details to create a pie chart. So a pie chart option, it is not giving us, but we can still do it. So how do we do it? Let us try to manage that. Maybe let's try to put that on size, but still it is not giving. So let us see how to actually create a pie chart even when it is not suggested. What is that it is missing? Let us see. So what's happening here is, if you are using count distinct as an option, then this pie chart will never get selected. Even whatever you try it, gender on color or anything, whatever you try it, that pie chart will never get selected. What you can have to do is, instead of selecting this measure as count distinct, you have to select this as count. As soon as you select count, the pie chart is getting highlighted. If you say count distinct, that means distinct values of customer ID only. If you try, pie chart is not getting highlighted. So Tableau restricts you to do certain operations, but that is one of the limitation. Whatever graphs that it is suggesting, beyond that, it will be difficult for us to draw unless until we are actually following the Tableau's rules. So what we will do is, we will try to make this as a count, then pie chart is getting highlighted. You simply click on that. Okay. What you can do is, you can take this value and you can put it on data label as well. Okay, so you just hold control. Once you hold control, you can also add it on data label. So these are the count values. You can also add data label on gender. So I'm holding control here, like on hold control button. Otherwise you can bring gender and put it on label. That is also fine. Or the better way to do it would be, since you're already in this graph, this way you can get it. Okay, so the data labels are these. If you want to change the type of calculation also, that is possible. Or if you want to, let's say there are 8,222 records, 66,000 records here. If you want to have a look at these records, this is one of the best property of Tableau. So let us say fit width, slightly bigger one. You can use this option called, let me also say fit entire view. You can use this option called view data. If you want to see what are those records, you can view data. Gender is null for these many records in customer profile table. Gender null, null, null for all these customer IDs. So you can have a look at the data as well. Or if you want to have look at this data, even in the previous one, if you want to have a look at all the customers who are from doctorate, you can view the data. Then it will give you that records. This is a very good property compared to other BI tools or other tools. They may not be giving you the data like the way that Tableau is giving you. If you can click on a particular point which you are interested in, and you can have a look at the data. Okay. So let us rename this. Let us rename this as gender analysis. Basically, univariate analysis is what we are doing. So what is, how many male are there, how many female are there, how many are null values? That's what we are checking here. instead of printing these values, if you want to make it like a table, this is the tabular form. Okay. Instead of the original values, if you want to make it look like percentage values, that is also fine. Let's say if one more value is what you are interested in. If you want to put another label here, but this time you want to make it like uh, quick table calculation. I want to take percentage of total. This is percentage of total. Female are 50%, male are 44%. Along with the percentage, I want to also show the values as well. Then what I'll do is again, I'll put it on the label that, you know, both customer ID, which I will be taking it as count as well as percentage. Both count and percentage, both of them are available. Okay. Both count and percentage. If you want to put them here, both of them should come in the row by row manner. That is also possible. Column by column manner. That is also possible. You can make a lot of modifications. In fact, you can also now come up with again, uh, bring it back to pie chart and put that as the label. That is also possible. You can again bring gender, put it as a label. That is also possible. So you can try different ways of displaying the data using this pie chart or using this tabular format. So we're done with education level, we are done with gender, we are done with bar chart, we are done with this pie chart. We are almost done with this tabular data as well. So how do you create data inside a table where you are showing percentage as well as count? You just need to click on that table or pie chart, the data will be automatically generated. Now that brings us to the first lab session for this. What is it? I want you to create a bubble chart for education level. And I also want you to format the labels. What is a bubble chart? A bubble chart has two properties. You have a bubble, this is known as a bubble, the size of the bubble as well as the color of the bubble. Size of the bubble indicates something, color of the bubble indicates something. Here, I simply want you to focus on only size of the bubble. There are more graduates compared to high school, compared to doctorate, compared to uneducated, like that. We have previously created a bar chart. Bar chart is actually sufficient for doing it, but for practice sake, what I want you to do is create a bubble chart. Okay, try this. This must be the final output. So try to open a new sheet, add a new sheet here. So you can use plus sign here as a new, add a new sheet, name it as education level underscore bubble, and then create a bubble chart. That's the first exercise. The second exercise is on marital status. So there is a column called marital status. So on marital status, I want you to add two more columns: count of customer ID, how many customers are married, how many customers are single, how many customers we are unknown and divorced or null. This is the first column, and what is that respective percentage, that also need to be displayed. It is a little bit tricky, but you will be able to do it. To get this percentage, you have to use that quick table calculation. That means you have to use customer ID for sure. So you will be double clicking on customer ID, then customer ID will be added. Then you will be converting that into count, and then after converting it into count, so you create a table like this and then click on tabular data, then make this as add a quick table calculation percentage of total. Now that is percentage. Again, you have to add customer ID. Again, drag and drop customer ID, repeat the same process. Again, click on the table, then you will get the final resultant table. So the resultant table should look like this. So that is your first lab exercise. Once you're done with the lab exercise, then we will move on to the next part of the discussion in our video. Okay. First complete this lab exercise. I'll see you on the other side. All right. Once you are done with that lab session, let's once again understand the difference between measures and dimensions. Because we hear this term measure, we hear this term dimension very frequently when we are working on Tableau. Dimensions are non-numerical columns in general. A dimension is a non-numerical categorical variable, something like gender. It takes values like male and female. Something like marital status, married, unmarried. unknown, something like that. Okay, or single or something like that. Region, east, west, north, south. You cannot find their average value. You cannot find the minimum or you cannot find the maximum. These are non-numerical values. They are called as dimensions. What are measures? You can measure them numerically, continuous variables. What are they? Income. You can find the average income. It's a range of values. Age, it takes a range of values. Number of loans, range of values. They are known as measures. Usually, if you take this data, educational level is a dimension, gender is a dimension, marital status dimension, monthly income. It is actually a measure, but it is actually read as a dimension here. That means there is something wrong with it. Inside the data, there must be something wrong. There must be some values that are non-numeric inside. That's why it is read as dimension. We will see that why, what's the issue there. Age. Now you see this hash. Hash means numeric. Age is a number. Customer profile table count, the number of records in that customer profile table is again a measure. Measures and dimension. Dimensions are usually in blue color. Measures are in green color. Again, this one monthly income is actually a measure, but it is read as dimension. That means there is something wrong behind the scenes. Again, if you see this, when you're trying to draw the graphs also, count is a measure. Educational level is a dimension. Education level dimension. Count is a measure. Measures are in green color. Measure, green color. Measures, green color. These are all measures, average value. And dimensions are education level, gender. These are in blue color, which are dimensions. So measures, what are measures? Once again, what are measures? They contain numerical data. They can be aggregated. You can find their average, minimum, maximum, age, income, sales. These are all measures. Measures are usually continuous or discrete numerical values. When the field is dragged into the view, Tableau automatically applies aggregation. When you drag age into the view section, either average age or minimum age or maximum age count or something like that, automatically aggregation will happen. Income, average income or minimum income, maximum income, that kind of average aggregation will happen, or summation of income or summation of sales, that will happen. They are generally highlighted in green color. What is a dimension? A dimensional field that can be used to split another field. You can use it to split another data, which means you can split the sales data by region. You can split the sales data by gender, male or female, something like that. It can be used to define the level of detail to perform the aggregation on. You can use it to perform the level of details so that you can do the aggregation. Okay. So basically, region wise, what is sales? Gender wise, what is sales? So that is the dimension. Okay. Examples are region, gender, marital status. Dimensions are usually categorical variables. They contain qualitative measures, not quantity, quality. Okay. Qualitative means categorization, segmentation, variables like that. They are usually highlighted in blue color. If you go to our target variable here in our data set, the target variable is whether the customer is a risky customer or non-risky customer. Since our target variable is read as 0 or 1, it is showing it as a measure, but it must be converted to a dimension. For us, customer is risky or non-risky, that must be considered as a dimension. So let us rename this and say target. Let us get an idea on the target variable. Okay, let me get rid of this marital status and this table. If you want to clean everything, there is this icon here. See this? Clear. Alt Shift Backspace. You can either do that or you go here and say clear. Again, let me show it. Control Z and then look at this. Clear. There is one cross icon here. Clear this. Then if I look at the target variable, which is default or risky, automatically sum is calculated. It has been calculated because it is a measure. Measure means 1 or 0 is taken. But I want to convert that as a dimension. So let me do one thing. Let me convert this as it's a measure. Let me convert that as, what should I convert? I should convert that as a dimension. Now, if I convert it as dimension, the graph is changing. Previously, automatically summation was done. Tableau automatically does the aggregation, but I'm not interested in aggregation. I don't want to do the aggregation. I want to convert it into a dimension, and then for this dimension, I want to see how many customers are defaulters. Historically, this is 2 years back data. How many customers were defaulters? Defaulter means bad customers. They did not pay back the loan. How many customers are non-defaulters? So let's get customer ID. So I'm double clicking on the customer ID and convert it into a measure, get the count. So defaulter, non-defaulters count. So this is converted into dimension now. So what we will do is we'll try to create a table here. So let me get that out. So right now it is taken as a dimension. Now it is showing as 1 0 in this manner. We are not interested in this table. Again, zeros and ones are shown. So what we will do is we will also calculate the percentage. Okay, count of customers. Let me do a quick table calculation, percentage of total. So we have the percentage of total as well, and then put it is on the label, or let me put it this percentage on the label. For some reason, this tabular table is not shown. Let us try to get that table. Let me put that as label. Let us see if this is used as text. Is it using default or risky? What are the values this is taking? Zeros and ones. Let us readjust this. Customer count and then customer count. These two are shown and default or risky. Looks like there are two tables it is taking. Let us delete that. Let's delete this. Let's delete this. Let's do it freshly. So let me get this defaulter risky, and then even though we have converted into a dimension here, it is still not working. What we will do is we'll come here and change the role itself. We convert it to a dimension in the data itself. Once you convert it to a dimension well beforehand, now it is turning into blue color. Otherwise, what's happening was even if we are bringing it here, even if we are converting it to a dimension, it is still in green color. Okay. So it is still somehow read as measure or something. So what we will do is we will come here and change the role, change the convert data type or convert it into a dimension. Now it is in blue color. Now click on that. Now get the customer ID. Get the customer ID, make it as a count of customer IDs. Measure count of customer IDs. And then again get the customer ID. So this time I'll select the table. In this table, I would like to first do the quick table calculation, percentage of total. And then I want to again get the customer ID, put it on label, get the customer ID, drag it on label, and then convert this customer ID into a measure which is on count. So this is how you do it. Again, when you click on that table, this is the table that I'm looking for. I can see that 93% of the people have paid back. They are not defaulters. Default means bad customer, they did not pay back. Okay, defaulters or risky customers. Or one means they are risky customers. So historically, 6% of the people, 10,000 people, 10,026 customers did not pay back. Whereas 93% of the customers, 1,39,000 customers, 39,974 customers have paid back. So for us, defaulter or risky, 0 or 1 is actually a dimension. We don't want to treat it like a measure. 0 means not risky. 1 means risky customer. This risky customer should not get the loan. So the analysis that we are going to do is within this 1, within this 6% of the customers, what are their traits, what are their type of habits, who are these 6% of the customers, who most of the people in this 6% are those the customers that are paying every time on late, or those the customers that are having different education level, are those the customers that are having different marital status or monthly income. What is it really impacting whether a customer who is going to be turning risky or not? Okay, so that's how you convert a measure into dimension. You change its role. Once you are sure that something is not a measure, it has to be a dimension. What we will do is, right now we have done the analysis of non-numerical variables, which are only dimensions. Now we will get into the analysis of numerical variables like age, debt ratio, existing loans count, etc., etc. For numerical variables, the univariate analysis slightly differs. We use pie chart. So before that, what we will do is we will end this video, and I'll make sure that you have completed the exercises before going to the next video.